All right, so in 1.2, there's going to be a homework problem, word problem that says something like a woman is making, and this is not in your packet because it's just one of the homework problems, $2,500 per month. And her salary is reduced by 20% because of sluggish sales, whatever it says in the word problem. 1 year later, just put because ... After a grade improvement, she's given a 30% raise. For her reduced salary. What is her new salary after the raise? And what is the percent change? Triangle means change. Okay, so that was what the word problem looked like. So she started off, she's making $2,500 a month, okay? She gets reduced by 20%. So think of the word of meaning multiply. If she is reduced by 20%, what percent of her original salary is she now making? How much, what percent was she making to begin with? 100%, right? She was making 100% of her salary and it's reduced by 20%. So what percent of her salary is she now making? 80% of her original salary. Remember, of means multiply. So 80% of the OG salary. All right, what is the original salary? 2,500, all right. And I told you of means multiply, so we're gonna multiply there. 80%, we need to put that in as a decimal, that's 0.8. So what is 0.8 times 2,500? 2,000? Yeah. So after she's reduced, her salary's reduced to 2,000. Then after a year, they're gonna give her a raise. So she's gonna make 100% of that 2,000 plus 30% more of that 2,000. So what percent of the 2,000 is she gonna make? She gets all of it. We said all of it was 100%, and she gets a 30% raise. So what percent is she now getting of her salary? 130% of the reduced salary, right? 130% of reduced salary. So 1.3 is 130%, or 1.30 if you want to write it like that. Of means multiply. Her reduced salary, we said, was the 2,000. So how much is she making now? $2,600. That's the new salary. That's how much she's making now. So that's the first question that it asked. You got to go through a couple of steps to get there. And then it says, what is the percent change? The percent change is the new salary divided by the original salary minus 1. Minus the 100%, okay? All right, so what is the new salary minus the, divided by the original salary? So that's gonna be, the new salary we said was 2,600 divided by the original salary is 2,500. What's that? Do shift equals 1.04, right? Minus 1 is 0.04. So that is a 4% change. So her raise was really 4% from her original salary. Okay? Any questions on that one? So if you get to 1.2, there's one question like that. Okay? The other questions are very similar to what we do in class, the word problems we do in class. Okay? Solving for y is on there, getting the y by itself. All right, let's look at section 1.3. We're going to look at graphs of linear functions. Talking about graphs of linear functions, we're talking about what a line looks like, what the graph of a line looks like, not a parabola, not a cubic, a line. Okay, and there are 3 forms that we can write our equations of line in. The first is the general equation of the line. So that's ax, some number ax, plus a number by plus c is equal to 0. 3x plus 2y plus 7 equals 0. That would be the general form. We don't use that form very often. Usually, the one students like the most is the slope-intercept form, and that's y equals mx plus b. Does that one look familiar to you? And then the one that we don't use very often in high school, algebra teachers don't teach it very often, but I do think it's an easy equation to use, is the point slope form. So that's when you're given a point on the line and you're given the slope on the line. It's y minus the y value of the point. So y minus y1 is equal to m, the slope, times parentheses x minus x1. Have y'all seen that before too? Okay, so m is your slope. And then there's some point x1, y1. That's just a point, okay? And that's what those things stand for. This one, notice, doesn't give us much information at all. Okay? When we have it in this form, it isn't that bad to graph, and we'll use your teachers in high school and the last class recognized the name cover-up method. Have y'all heard of that, where you cover up part of it? Some teachers say it, I never said it that way, but I've always had students who learned it with that. So we'll talk about that, okay? The points where the graph intersect the x-axis are called the x-intercept points. The x-coordinates of these points are called the x-intercepts. And what it means is we have a value for x, but the value for y will always be 0. It's on the x-axis. If you're looking at the axis, this is your x-axis, this is the y-axis. There's some number here, x, 0, because we haven't gone up or down. Okay? The points where the graph intersects the y-axis are called the y-intercept points. And where they intersect are called, these points are called the y-intercept. And for those points, the x value is 0, and we have some value of y. So that would be on the y-axis. The x value is 0, and we've gone up or down some amount y. Okay, to find the y-intercepts, we set the x value equal to 0. To find the x-intercept, we set the y value to 0. Okay, so that's all we would do with the equation. All right, so it says in the next example, we have an equation x plus y equals 1. So it says to find the y-intercepts of the equation, we set the x value equal to 0. So we're replacing the x with 0 plus y equals 1. So y equals 1, and that would be the point 0. That was my x value, and my y value is 1. Does that make sense? To find the x-intercepts, we set the y value to 0. So intercept. Now we do the x-intercept. So we do x plus 0 equals 1. X equals 1. So 1, 0. Okay, if we want to then graph that line, we could graph those points. Over 0, up 1, over 1, up 0. It only takes 2 points to draw a line. So connect those. And we've graphed the line x plus y equals 1. Right, the next one we have 3x plus 2y equals 9, and we want to graph it. I'm going to show you what I mean by cover-up method, okay? So let's say we want to start, we know we need to find when x is 0, and we could do the work of plugging in 3 times 0 plus 2y equals 9 and solve for that, okay? Or if we know we want x to be 0, we can cover up where the x is. And we can solve for what y would be. What fraction would y be? Almost. We want to get rid of the 2, right? So we're going to divide both sides by 2. So it's 9 over 2. Okay. When y is 0, we cover up the y with our hand or our finger. And what is x? What are we dividing both sides by? 3. So that's going to go away. X is 9 divided by 3, 3. Y'all see it? If you want to do the work, you can. So that would be 3x plus 2 times 0 equals 9. And then you could solve it from there. So then we can graph these 2 points. And if you need to figure out what that is a decimal, just put it in your calculator, 9 divided by 2. You should get 4.5. Okay, so over 0, up 4.5, over 3, up 0, and then just as neatly as you can, connect the points. 3x plus 2y equals 9. All right, this one's a little trickier. Yeah.
So the top one when x is 0, And the bottom one will be 0.
Yeah, so when I start these problems, I always do this. I know I'm gonna have a 0 in front and I know I'm gonna have a 0 in back. And think of this as X, Y. When the X is 0, cover up the X.
Okay,
When it's in the Y place, cover up the Y.
okay, thank you.
Mhm. Again, like I said, we're gonna have a 0 for X. I'm gonna have a 0 for Y. In the first one, when I cover up the X, I get 4Y equals 0. So what is Y? So I have 0 equals 4Y. When you divide by 4, what do you get? 0. 0 divided by 4 is 0, right? When I cover up the Y, I get X equals 0. That only gives me 1 point. So then I can find another point on the line, because if it goes through 0, 0, that is both the X and the Y intercept. So it doesn't give me much to go on. So then we can just pick a number that you want. So Kenzie, give me a number to plug in for X. 2, okay. So 2. And then when I want to find what Y is. So that's 2 equals 4Y. What would we do to get the Y by itself? By 4, right? So Y equals 2 divided by 4, or that reduces to 1/2. Everybody follow that? Yeah? No? Maybe. Sorry.
Like, why'd you just put in the random number?
Because I only had 1 point and I needed to find another point. And so on a line, do you agree that any line I draw, there are all values of X? There's always going to be a point on where I go up or down and I'm going to see the line. So I can pick any X value I want. Some might give me nastier fractions than others. But like if I had put 4 right here, I would have gotten a 1. But if I had put 3, I'd have gotten 3/4, and that would have been hard to graph.
So if it's y equals like 4x, would you do the same thing?
Yeah.
Okay.
Yeah. Yeah, just pick a number for X. And when it has a number in front of the X, it'll give you a nice number every time you pick for what you pick. This one, the way this is written, it's going to give you a fraction, which is why I tried to get somebody to give me a value for X so you could see that getting a fraction when it's like that's okay. Okay, so we've got the point 0, 0, and then we've got the point over 2 up 1/2, and you just do the best you can do, because I can see, if you're showing me your work, I can see the points that you're trying to graph. Now, on the computer, on your homework, when you put in these points, you're going to go and make sure that when you're guessing those points to put in, if it's a fraction, that it tells you the point that you said it did. So you're going to go over to the right hand side. You'll understand when I say this, but when you've got your graph, it'll say points, and you're going to make sure those are the points that you wanted it to graph. Okay. And if you have trouble with that, this is where some students had a little trouble with graphing lines. It's more in the shading part that they had trouble with, but let me know and I'll help you. Y'all just make sure you bring your computers to class so I can look at it and help you with it. Okay. All right. Any questions with that? Slope and rate of change. So slope is just another word for rate of change. And the reason why it has 2 names is because when we look at a line has a slope. But when we get talking about curves, it doesn't have a slope, but we can look at between 2 points and see that a line can be formed between 2 points. And so that imaginary line that's between the 2 points is the rate of change. This doesn't have a constant slope, but it does have a constant rate of change. Okay, so it just got fancy in the words, but the 2 things mean exactly the same. So the rate of change of a linear function is called the slope of the line. For a graph of a linear function, the ratio of the change in y to the change in x of the slope of the line. So it's the change in y over the change in x. And we'll get to that formula for that in just a minute. So I like to snow ski, okay? And there's two types of slopes that I try to avoid. One looks like this. Okay, if I see a mountain that looks like that, I try to avoid it. And one looks like this, okay? If I ski down a slope like this, what's probably gonna happen to me? Fall, and if it's a really steep slope or a really tall slope, I'm probably gonna do what? Die. So I'm gonna be undefined. So the slope of a vertical line is called undefined because that's not possible to go down. Okay, a slope of something like this, if I'm gonna ski across this, I'm gonna have to work a lot, right, to get across something flat. It's no fun or no slope. It has a slope of 0. So mathematically, what makes it 0 and what makes it undefined comes from the equation of it. When we're writing a slope of a line, and you see the equation of a line, it would look like x equals, and it would just be some number over here. When you see a line that is a no slope, it's going to be a y equals a number. There's not going to be an x in this equation. There's not going to be a y in this equation. It's going to be x equals 3 or y equals 7. So the reason why that happens, we said it's the change in y over the change in x. So it's one of the y values, so y2 minus y1 over x2 minus x1. And that's when you're given a point, x1, y1, and x2, y2. It doesn't matter which of the points is the x2, y2 point and which is the x1, y1 point. So it doesn't matter which one you start with, as long as the first y here is the first x here. So the points kind of go together vertically. Okay, we don't want to put a y2 here and an x2 here. All right, so what happens when we have this undefined slope here is that when we do this math, we get y2 minus y1 over 0 because the x value was the same. And we can't divide by 0, and that's what makes it undefined. Here, we get 0 over x2 minus x1. Well, anytime there's a 0 in the numerator, that's 0, and that's why the slope is 0. Okay. All right, so I've got 2 points there. I've got -2, 1, and I've got the point 4, 3. All right, so Trinity, do you want this group to be my 1s or my 2s? 1s. So when she says that she wants that to be 1s, what that means is this is going to be x1, y1, which means that this one over here needs to be x2, y2. Okay, she could have said that this was my 2s, and that would have made this x2, y2, and x1, y1. It doesn't matter as long as the pair has the same subscript. Okay.
Never mind. I forgot what I was gonna say.
Sure. If it comes back to you, let me know. All right, so if we plug into this, we get 3 minus 1. I pick my y's first. Really bad habit of students is to put your x's on top. Saw that so much on the last test, the test last semester. Remember, your y's go on top. The back end goes first. All right, we started with this 3, so we're gonna start with this 4. 4 minus -2. What is 3 minus 1? 2. A minus negative becomes a what? A plus, so 4 plus 2 is 6. And we could reduce that to 1/3. You don't have to reduce it. Okay, try the next 3 with a partner. Yeah. Which one? That changes the plus.
Yeah,
Put,
that's
you
right.
put that in the cap, do negative, here's your negative sign.
Oh, so you want, start out in here.
See how these two are right next to each other? That's when it becomes a plus. These two are next to each other. So it's, if you, this is like saying, oh, you owe me 3,
This one for the first.
and I'm gonna take 0 away from them. If I take 0 away, you still owe me 3, so it's still negative.
Which one? Yeah. That would be like undefined or something, I think.
When it's in the denominator, it is,
Okay, so,
and that would be 0. So it's
okay.
So just in this situation, because I'm too, because I saw the situation when I put.
that would become the plus.
Okay.
Yeah.
Thank you.
I think 2 minus -2. So that minus negative becomes a plus, so -2 plus 2.
I'm thinking we just. wrote it in there.
Oh, no, the front one has to stay.
It's snowing.
It's all right.
It's been saying it's snowing for like an hour or so, but it hasn't. Actually.
It's nice, there are little flurries outside.
Oh, yeah.
All right, y'all ready for me to work through them?
Mhm.
Kenzie, y'all good? Your group? Okay. All right, so y2, so -3 minus 0 divided by 4 minus 3, which is -3 over 1 or -3. And this is m, so we want to put m equals. Okay, if you left it -3 over 1, I wouldn't count off, that's fine. Computer might not like it very much, but all right, this one, so it's 4 minus 1 over -2 minus -2. So 4 minus 1 is 3, -2 plus 2 is 0. So I have a 0 in the denominator. That's when it become undefined. So that's a vertical line right there. And just to show you, at this point, I could write the equation of the line. The equation of the line is going to be x equals, well, what did x equal? You see it was the same thing both times. So the equation of this line is x equals -2. It's a vertical line at -2. Okay, this one we have to do a little more work to get the equation of the line, but this one we know. All right, this one, we've got 4 minus 4 divided by 2 minus 1. That's 0 over 1. A 0 in the numerator, that's m equals, I should have put an m equals here, m equals 0. When it's 0, it's a horizontal line, it's flat. Where is it going to be? It's going to be at y equals, what's y equal to? Or that would be the equation of the line. I didn't ask you for the equation of the line in that problem, but when you have undefined and when you have 0, we can write the equation of the line very easily. You can look at it and see what's the same, and that will help remind you whether it's supposed to be x equals or y equals, because these are x equals the same thing. These have both had a y that was equal to the same thing. Okay, so now let's look at a point slope form. We're going to write the whole equation of the line when the slope isn't 0 or undefined. So we have to do a little bit more work. So we need to find the equation of the line that passes through -2, 1, and 4, 3. Okay, our first step is to find the slope. So everybody do it with me on the paper. See if you can start working without looking at the board and get the slope right. Did everybody get 1/3 or 2/6? Okay, awesome. So what I want you to see next is using that point slope. So y minus y1 is equal to m times x minus x1. Okay, with this first step, I might get a different answer depending on what I choose to be my x1 or my y1. But if I kind of then combine it, I get to the same answer. So I'm going to show you this problem both ways. And then I also do y minus y2 is equal to m times x minus x2 to show you that I could pick either point to start with, okay? So y just stays a y. Minus y1, 1, equals m, we just found m, 1/3 times x stays an x, minus x1, -2. Is everybody good with what I just did there? All right, Cam, talk to me.
What is it?
Okay, so here's my original points, right? All right, and before, on the other page, I wrote that equation. Okay, I used that point slope equation because I have a point and I have a slope. All right, so I just plugged in my y1, my x1, and my m. Now, I'm going to simplify this a little bit. So y minus 1 equals 1/3 times. I'm going to go ahead and change that minus negative to a plus. X plus 2. And I'm going to take this to slope-intercept form. Now, some of you guys, if you did algebra 2 or pre-calculus, when you did that, you may have started off using y equals mx plus b. If that's what you're used to, you surely can still do that. You're gonna get to the same answer. Okay? So I'm gonna now distribute this 1/3 to each thing in the parentheses. So y minus 1 is equal to 1/3 x plus top times top, bottom times bottom. So that's 1 times 2 and 3 times 1. If you don't know what that is, use your calculator. It does fractions, but it's 2/3. And I'm going to try to get that y by itself. So I'm going to add 1 to both sides. Plus 1, plus 1. Again, use your calculator. Y equals, and I want to keep it as a fraction, 1/3 x plus 5/3 is what I got. Please check it, make sure you know how to do that on the calculator. Don't just copy off the board for me, okay? Make sure you're doing that math so you know how to plug it into your calculator. Got a question?
You want to keep it a fraction?
I do, yeah.
So this is 5/3 because 3/3 is 1/4, right? Okay.
Correct. Good. What? Calculator.
Oh, you added 5/3. So we're adding 1, right? So 2/3 plus 1. So 2/3 plus.
You good? Awesome. Now, I just want to show you, you don't have to do it 2 ways, and this one you can just watch if you want to, but I just want to show you that if I had chosen not to use the -2, 1, and I had chosen to use the 4, 3, that I'll get the same answer. So y minus 3, the y value there, is equal to slope, the slope is still 1/3, times x minus the x to 4. Okay, again, I'm going to distribute that 1/3 through that parentheses right there. So y minus 3 is equal to 1/3 x minus 4/3. I just multiplied the 1/3 times the x and then the 1/3 times the 4. And then I'm going to move the 3, so I'm going to add 3 to both sides. Y equals 1/3 x plus 5/3, because that's like 9/3 minus 4/3. So that would be 5/3. And you see, once we do that, we get the same answer. But it looks like we're not going to get the same answer when we start off and we plug in. So it doesn't matter which one you pick to be your x1, y1, which are the 2 points, as long as you're continuously using that pair. Okay, we don't want to pick an x from one and a y from another.
Confused on how you got 5/3 and 4/3.
So here, right here, this math. So if I do that math by hand, do you agree that to get a common denominator, 3/1, I'm gonna have to change that to 9/3?
Oh, okay.
Yeah.
I got you.
Anything else there? But yeah, you've got a calculator the whole time on everything we do, so if the fractions mess you up, don't worry about that too much. Just rely on that calculator. All right, so here's what I want you to do on the next page. We have a point and they're going to give us a slope. So it says, write an equation of a line that passes through the point 1, 2. So that's going to be x1, y1. And the first one says it has a slope of 2/3. Now I want you to think about this. We have a point and a slope. So thinking about those three equations that I gave you at the very beginning of class, which equation are we going to use? It has a point and a slope. Point slope. Point slope, okay? So go ahead, we're going to use that y minus y1 is equal to m times x minus x1. All you have to do is plug in. It doesn't say you have to take it to slope-intercept form. If it doesn't say take it to slope-intercept form like we did right here, we can leave it in point-slope form. The directions didn't say to go all the way to there. Just write it like that. Just plug in the values. Everybody get that? Now, just so you realize, when we started here, this was point slope form. This down here was slope intercept form. So sometimes the directions on your homework are going to say, write the equation in point slope form. So you just stop right there. Sometimes you'll get there and it'll say, write your answer in slope intercept form. And that's when you have to get the y by itself. Okay? Yeah. Okay. Can we move on? Good. All right. The next one says, write an equation for the line that goes through this point. So we're still doing this point, but it has an undefined slope. Anybody got an idea where to start?
Y being 0.
You're close. All right, if it has an undefined slope, I told you that one of the things said x equals and one of them said y equals, right? Which one was the undefined slope? It's a vertical, and what did I tell you about the vertical? If we're writing the equation on a line, it should be x equals something, right? Okay, so we know that this is going to be x equals, well, somebody tell me what x equals. 1. That is the equation of the line. X equals 1. It's just the equation line when it's undefined is just x equals some number. So what would that look like on the graph? Here's my XY axis. X equals 1. Well, here's 1. So it's going to be a vertical line at 1. Okay. The next one says that we have, and we want it to go through this point, and we want it to go through the point 2, 3. So that's like this guy right here, where we have 2 points. So can I erase this part underneath here? Yeah. So we want it to go through this point, and we also want it to go through the point 2, 3. So that's x2, y2. So what do we have to do first? Look over at the example to the right if you're not sure. What do we do first? What's that? You can't put in the formula yet. What do we have to find first?
Slope.
The slope. We have to find the slope first. Okay, so the first step when we're given 2 points is to find the slope. So y2 minus y1 over x2 minus x1. So we're going to find the slope first. So everybody find the slope? once you have the slope, everybody get 1 for the slope? Did you get 1? All right, then we're gonna do our point slope formula. So when we do our point slope formula, you can cross out one of the points. Doesn't matter which one, either one. I'm just gonna cross out that one. Okay, and then we're gonna use the y minus y1 is equal to m times x minus x1. Okay, it did not say we had to take it to a slope intercept form. So all we have to do now is plug in the slope and plug in the xy point. So y minus 2 equals 1 times x minus 1. And we can leave it like that. Okay, good. All right, in general, vertical lines have an undefined slope. We already talked about that. At the point of the equation where x equals some number. Okay, no other variable, just x equals a number, or x equals a. Horizontal lines have a slope of 0. And the equation is in the form y equals some number, or in this case, if we want to give it a letter, y equals b. Where b is just a number, it doesn't have any variable on it. B is the y coordinate of every point on that. Okay, so if I have the line y equals 2, it's a horizontal line at 2, right? So this is the point 1, 2, 2, 2, 3, 2, negative 1, 2, negative 2, 2. The y value is always 2. Okay. Point slope form with a y-intercept point of 0b can be used to derive a special form of the equation. That's what we already did when I took it down to slope-intercept form. So if we have y minus b is equal to m times x minus 0. Okay, it's the point 0b. We don't know what the slope is, right? Okay, so if we solve this, we're going to distribute that m. Y minus b is equal to mx. M times 0 is just 0. And then if we add b to both sides, we get y equals mx plus b. M is my slope, and b is my y-intercept. That's the value where the graph crosses the y-axis. So let me show you what I mean by that. If I have y equals 2x plus 1, okay? This means that I have a slope of 2 and a y-intercept of 1. So let's say I want to graph that. I start with my y-intercept. That means that it crosses the y-axis at 1, right there. Y-intercept is 1. From there, I use the slope. Remember, this slope has a numerator and a denominator. What's the denominator if it's a whole number like that? 2 over 1, right? So this is up or down. Positive is up, negative is down, and this is right or left. Huh? It's right in this case because it's positive. Okay? So I'm going to go up to, from this point, I'm going to go up to and right 1 to get another point. Up to, right 1. And I can keep going up to, right 1. And those points will all line up. And then when I connect them, I can graph my line. So you can graph in slope-intercept form, and you can graph with the cover-up method. When we're in y equals, we want to graph with the y-intercept and the slope. When we're in ax plus by equals c, we want to graph with the cover-up method. I had some students try to change that ax plus by like the first thing that we did when we did cover-up method because they like graphing out of this. It does not always work out nicely when you do that. Okay, I tried to make the cover-up methods work nicely for you. So if it looks like a cover-up method, use the cover-up method. Do y'all know what I'm saying when I say that? Yeah. So if I see an equation that looks like this, ax plus by equals c, to graph it, I'm going to do that x is 0, y is 0, and then I'm going to cover up the x and figure out that value, and then I'm going to cover up the y and figure out that value. And I'm going to graph those 2 points and connect it. If it says y equals mx plus b, I'm going to go to my y-intercept, graph that, and then use my slope to go up and over or down and over, okay, depending on whether it's positive or negative. Yes, no, maybe. With a little practice, yes? Okay. All right. Okay. On the next page, the slope-intercept form of an equation. Of a line with a slope of m and a y-intercept of b is y equals mx plus b. If a linear equation has the form y equals mx plus b, then the coefficient or the number in front of the x is the slope. And the constant term, meaning the number without the variable, the number that's right here, is my y-intercept. Okay? All right. The population of guinea pigs in thousands projected from 2000 to 2060 can be modeled by the equation y equals 1125.9x plus 142,690, where x is the number of years after 2000. Find the slope and the y-intercept. So, which of these numbers is my slope? 1125.9. The number in front of the x is my slope. What is the y-intercept? Good. What does the y-intercept tell us? Okay, so the y-intercept tells us when x is 0, okay? And it says that x is the number of years after 2000. So y-intercept tells us when x is 0. So in this case, it tells us the population at year 2000, because that was my starting year. Now, the next thing we're gonna talk about is slope and how to interpret the slope, okay? So our slope is that, right? So next to that, I'm gonna write change in y over change in x, and this is gonna help me define this. Okay, so what was my x?
What was the left hand word again? I thought of that.
But anytime I don't have a denominator, there's a 1 on the bottom. Yeah. What is the x? What did it tell us that x represented?
Number of years since.
Year since 2000, right? And what does it tell us that the y is? Population of guinea pigs in thousands, right? If you write this out, it's going to help you get your script that we need to write to explain the slope. You ready? It's going to be the same thing every time. The only thing that's going to change are these words right here and that number. For each change, and I'm starting right here, it's 1. For each change in year since 2000, and we're going to keep going around the circle, the population of guinea pigs in thousands is expected to, that's sort of my statistics piece in there, should change or should increase or decrease. Is this positive or negative? It's positive, so should increase because it was positive, decrease if it's negative, by that number, 1125.9. And I already said the in thousands, so I'm not worried about that. Okay? For each change in whatever you defined it by, keep going around the circle, should increase if it's positive, decrease if it's negative. Okay, that's how you get that script. But you got to kind of write this out and keep track of what your y and what your x labels is. Just like when we do a word problem, we say let x equal, that we're still doing that. Those words are still helping us get that answer. Okay? Any questions? That's a script you're going to use every time. That's on, I promise you that's on your test. Right there. All right. What time we get out? 45? Okay. I'm going to end this because that's all that is.